I would now like to invite Mr. Abhijit Chaudhary, founder Niral Networks, to deliver the keynote address on the subject, Will Private 5G Power the Next Generation Deep Tech? Over to you, Mr. Abhijit. Thank you.
Hello, everyone. Good afternoon. I'm Abhijit Chaudhary. I'm the co-founder of Niral Networks. At Niral Networks, we are building a private 5G and edge platform. We have witnessed the last decade where we have seen consumer-facing applications like Ola, Flipkart, Swiggy, Big Basket. It has redefined the way we have been living. Similarly, during COVID times, we have witnessed how Zoom, AWS, Zoho, Slack has transformed the way we are working. Now, let's take a pause and look back. If you go behind, you will see that under the hood, connectivity has played a very key role in this digital transformation. It had played a very foundational role along with cloud to disrupt and make our life much more comfortable and easy. I would say that Wi-Fi, 4G, and cloud has transformed the way we live and work till now. But in the coming decade, we will see a disruption of emerging deep tech technologies coming by. Let's take a mining area, which can be pretty big, like can be 2 square kilometer to 20 square kilometer. And to make the mining autonomous so that we can save lives, we would like to do the drilling, the blasting to be done remotely guided. And then after the blasting is done, we would like to have an autonomous vehicle, for example, a drone, doing an aerial survey of that area. And then an autonomous guided vehicle can probably collect all these mining ores, the extracts, and take it from the cave to the outside area. So these are some of the operational technologies which would come in place for the mining automation. Similarly, when you go to a port can be very big, like covering again around 10 square kilometer to maybe 40 square kilometer. Now, there are thousands of containers lying there. So we need to do automated tracking of that. So you can have a drone with a QR code embedded on that, and with a surveillance, you should be able to remotely operate the drone, do the tracking of all the containers, and basically optimize the logistics. Similarly, when you talk about an oil and gas refinery, there are billions of IoT devices to be monitored. And it is super critical that we get the information of all these devices in real time to ensure there is no human calamity. When you go to a very huge IT campus, let's say some of the campuses that we have, in Bangalore, Delhi, Mumbai, etc., you have a parking system management, a irrigation system within the garden to be managed, the lighting control system, the energy meters, security communication, security personnel communication, then the video surveillance. Now, all these technologies are what actually defines the operational technology. These are used to operate a mining site or oil and gas or an IT campus. And predominantly at this point, most of the operation technologies have been running in silos. They are not really connected, because one of the important reasons for that is that when you take such big campuses, can be a port or oil and gas, these are very big areas, like sometimes running to 100 square kilometers, very massive areas. So to connect the entire area, you need a connectivity which can scale. Let's take Wi-Fi. What are the existing technologies we have? We talked about Wi-Fi being transformational for our user need, like using the Ola and the other apps. But when we connect the Wi-Fi within a campus as big as that, like the Wi-Fi distance it can cover, like between two Wi-Fi access points, is around 100 meters. So that if you have to put to scale a 10 square kilometer of campus, oil and gas campus, for example, it will need thousands of such Wi-Fi access points to be connected. It's really not scalable. And in fact, it will not be efficient too. What is the other option? We talk about 4G, right? Like 4G has also played a transformation role till now. But when you talk about 4G, I mean, one thing that you have to see is that when you talk about a campus, we always talk about private networks. Like Wi-Fi network is generally a private network within that enterprise. It's not like a public network. So predominantly, most of the 4G networks currently are public, provided by the operator. So you need security because all these operation applications I talked about, like video surveillance, employee communication, you do not want those to go to the cloud or to go outside your LAN, outside your network to the internet. It has to be well established within the campus. So we need a private network similar to Wi-Fi, but which can scale. Now, one part is the scaling on connectivity, but apart from that, there are some more specifics that we need on that scale front. So we are talking about like AR, VR. We are talking about deep tech technologies like drone-based surveillance. We are talking about robotic automation. Now, all these technologies need lot of bandwidth. Like, for example, you may need very high bandwidth for a robotic automation to take place, like where the robots are moving from one place to another, and there are multiple robots. So you need to collect the video signal from multiple robots to be computed and again send back to that robot to decide whether it should move left or right based on the position of the other robots. So now there is a lot of video bandwidth, so you need high bandwidth. The next thing is that you need to decide soon. So the latency, the round trip or the response time for the robot to be moving left or right should be very quick, right? So that also needs a low latency. And I talked about oil and gas, where we need like millions of IoT devices to be managed within a square kilometer. Now that needs massive scaling on the technology. So this is not ideally what 4G was meant for. And that is how 5G has come into picture, and 5G would be transformational in that respect. When you come to 5G, 5G has key fundamental aspects and also some other secondary aspects which make it really useful to create a private network. The first thing is that the 5G network for each of these drones can guarantee a bandwidth of around 2 to 10 Gbps on uplink and downlink, theoretically. So it has a feature called enhanced mobile broadband, which will ensure that you have such high throughputs. The second feature is about the response time. It would provide a network which is highly reliable in real time, and it will guarantee that you can run low latency application of the of around 1 to around like 20 milliseconds can be run. Lastly, the other fundamental thing is that it would enable massive machine type communication. Like that would enable your like multiple IoT devices, like millions of IoT devices to be scaling and be connected to the network within a square kilometer. And it will also ensure low power. So these are the three fundamental things: enhanced mobile bandwidth for broadband for high bandwidth, ultra reliable low latency for low response time and giving a real-time effect, and lastly the massive machine type communication to enable like millions of devices to be connected. So that will really enable a lot of deep tech applications to be run now. But along with that, you also need some more things. And to start with, 5G actually provides some other secondary benefits too. Like firstly, it is disaggregated. and software plays a very key role. So unlike the traditional technology of 4G, where like you had most of the it was very controlled from a vendor and from a specific vendor. When you create a 4G technology, you have to use that technology from a single vendor and predominantly hardware. But in 5G, what has happened is that that device has got disaggregated predominantly into software, which can run on any off-the-shelf servers. And then parallelly, you have some of the critical parts, like, for example, the radio component, which gets the 5G signal, that would run as a hardware, but anything else are running on a software commodity server. And the second part is that you can take radio from one vendor, let's say vendor A, and you can take the software for running the baseband, which is part of the radio processing, from a vendor 2, that is called like the radio disaggregation. Then you can take the core technology, which is used to manage multiple radios, from a third vendor. So that's talking about how the network is getting disaggregated and multiple players are coming into play, and a lot of even small companies like us and many other companies are coming to play in this and to create a solution which can be disruptive. So apart from this, there is also a need for the applications to become real time. So I talked about the network using 5G, but also the applications to become foundationally run very low with low latency. If the applications are running in the cloud, it will take a long time. So it will not, though the network, the 5G network can be very low bandwidth, high bandwidth and low latency. But still, if the applications are running on the cloud, then the bottleneck is the cloud. It will take around a second to reach to the cloud and get a response. For your applications, like maybe the AR/VR or the tracking application using the drones, etc., it will take a long time. So the cloud also has to move towards the edge, or in fact on the location. So you need to disaggregate the cloud, and most of the compute application like the analytics or the drone video surveillance, all those the applications, all the fits has to come onto the edge or within the premise of the enterprise or within that campus. So you can say that to ensure deep tech applications, emerging technologies to really run for a large campus or for a mining, you need to use a private network, secured network, and you need to use the 5G technologies for that. And then you need to bring the cloud to the on-premise. That means you need to bring the cloud to the cloud servers inside the premise, inside the site, and you have to do the compute within that site. So when you bring these three together, that's when you can really reap the benefits of and run the emerging deep tech technologies that are required. So the 5G now becomes private 5G because you are running within a premise, and it is an alternate, or it would work along with the Wi-Fi network. Wi-Fi network is also a private network, but it would cater to the operational application. My mistake. So it will cater to the information technology applications, like your Zoom call or your like the Zoho app that you are running, or your bug fixing app, etc. Those are IT applications. But for running your operational applications where you need mobility, you need much bigger wide connectivity, you need lower latency because it's mission critical and need real time. So for that, you need to use a private 5G network, which is private and also uses all the capabilities of a normal 5G network. And lastly, to ensure that the apps responds on time, like we talked about the robotics, like the robot has to send its feed to the network, to the application, and the application would take feed from all the other robots within that area and then send a response to the robot, whether it should move left or right or stop, etc. So all this compute has to be done in sync on the edge compute, which is working on that site itself. to ensure low latency, guaranteed low latency of around 1 to 10 milliseconds with a high throughput of around 1 Gbps. So this is a massive opportunity. The 5G and edge is almost a $517 billion opportunity, which is being worked upon. And out of them, industrial automation or industry 4.0 and the metaverse, which contains the video gaming applications and also the video surveillance, AR, VR, this takes a big chunk of this $517 billion opportunity. So at last, what I would like to say is that private 5G will redefine how deep tech technologies will be used for predominantly industrial operations. And private 5G will become very widespread, especially for operational technology usage, similar to how Wi-Fi is widespread and ubiquitous for information technology. So all the like coming emerging technology, especially in the metaverse or in the industrial operations or in the robotics or autonomous guided vehicles, I think private 5G will play a very critical role. And it would, along with the edge, of course, the edge also would play a very critical role to enable a lot of emerging applications to show and basically unleash all these applications to its biggest potential or highest potential. Private 5G and edge are going to play a very fundamental role. And with that note, I would like to end, and thanks for your time.